Hi, I'm Liam, and I'm part of the Gigabyte marketing team for enterprise products. And today, I'll walk you through some of our HPC solutions using the powerful AMD EPYC processor. With PCI cards like the AMD Instinct MI100 and the newly unveiled OAM form factor AMD Instinct MI250 for exascale computing. To deliver a solution for diverse needs, Gigabyte has over 75 servers and server motherboards specifically for AMD EPYC 7003 processors. For HPC, we have two lines of servers. On the far right, the G series for GPU-centric workloads, and H series for the high-density applications, such as the 8 CPUs in a 2U node for high CPU compute. The EPYC 7003 series has made a big splash in the enterprise market, so I want to point out four important characteristics on the right side of this slide. Servers are more efficient as they have more choices for balanced memory for memory-bound users, and L3 cache is doubled to aid large datasets. Security improved with the addition of secure nested paging for added security for virtual machines. And for performance, there is an uptick in clock speeds and instructions per clock. Last, the 7003 series CPUs are backwards compatible with servers that were bought for the 7002 series. Now let's take a look at the new MI200 series. For HPC performance, the AMD Instinct MI250 accelerator will bring sizable benefits. With the introduction of the AMD MI200 series, we can now reach a new level of computing capability at exascale with a new breed of GPU accelerators. As a result, massive supercomputers will break the exascale computing barrier of 1 exaflops, or 1,000 petaflops. Unifying this new MI250 with the 3rd gen AMD EPYC processors deliver the greatest compute level possible with outstanding performance per watt. And as AMD's open software platform, ROCm, has matured, customers can get access to optimized workloads, compilers, libraries, and ML framework containers to be used with MI200 series accelerators in HPC or AI. For the HPC market, the MI200 will target academia, sciences, and government. Obviously, for supercomputers to show their potential, they need to do so in a cluster. It's the combined effort of each server, but we will focus on the individual servers for today. Fitting two EPYC processors with an outstanding 8 AMD Instinct MI100s in a 2U chassis is what the G292Z44 delivers. And it is able to do so without throttling performance, so you can achieve peak performance. This G292 server is just an example of how high-performance computing is able to process data and perform calculations, while heavily relying on parallel processing from the GPUs. Also, there is extra venting on the sides to exit hot air and pull in cooler air. If the goal is to have as many PCIe-based GPUs as possible in an HPC server, the G492Z51 checks that box. As the GPUs are all behind a massive wall for cooling, it leaves the front half for AMD EPYC. And there are 12 drive bays for NVMe and SATA drives. And continuing with the front of the case, there are dual 10 gigabit Ethernet LAN ports for communication and two low-profile Gen 4 slots for NICs. This design allows for all communication and hot swapping to be centralized on the front for quick access. And turning to the rear half of the server, we have room for 10 AMD MI100 accelerators. 8 are slotted directly into the motherboard, with the 2 on top using PCIe ribbons to connect. Because this configuration is unique, I want to take a quick look at the block diagram to understand how 10 AMD MI100s can be well supported. Towards the bottom of this image, you'll see 2 Broadcom PCIe switches to achieve this feat while maintaining low latency. And when we look at the 2 EPYC CPUs, we can see each has 16 DIMMs available per socket to support up to 4 terabytes of memory. Up to this point, we've been focusing on GPU technology, but we must also account for CPU-centric workloads. So that's where this 2U server with 24 U.2 Gen 4 bays comes in. This is a H.262ZL0, and it is actually a 4-node, 8-socketed EPYC server that uses direct liquid cooling with the help of CoolIT systems. The use of this cooling method allows for 280-watt CPUs to run at optimal temps without throttling, and the heat is removed through the liquid. And to manage the system is a CMC port for efficient communication. When less storage is needed and peak CPU performance matters, the H.2A2ZC0 steps in with an all-air cooling solution. This server is also different in that the 4 nodes can be accessed from the front of the server, not just storage as in the prior H.262 server. And as some storage bays have been removed, greater airflow can enter from the front as air is pulled across the sockets, M.2 slots, and RAM to exit out of the rear of the case. And at the rear are a total of 8 low-profile expansion slots. Alternatively, you could use the front 4 expansion slots and 4 OCP slots instead. Last, at the front is all your COM ports with the CMC ports in the rear. Today I want to highlight one of our success stories that was for HPC applications. IFISC is a research facility in Spain that studies fields such as environmental sciences and biosystems engineering. For their projects, they required high compute for HPC, simulations, AI, and big data. They approached Gigabyte, and we delivered a cluster of our G482Z54 servers with dual AMD EPYC 7282 processors and GPUs. This allows them to study pathogens and pollution that are afflicting an important seagrass species in the Mediterranean. Before I conclude today, I want to remind our audience that Gigabyte works with software partners to validate systems. If a customer approaches us about getting Gigabyte servers validated with, say, SUSE or VMware, we can submit the servers for them as we have a process and connection in place. Well, that wraps it up for me today. We invite you to join Gigabyte at our various platforms to learn about our enterprise products. For further questions, you can email us directly at server.grp@gigabyte.com or visit our enterprise page at gigabyte.com/enterprise. I'm Liam. Thanks for your time today.